we look at notice now 7. Okay, we are told that the probabilities of 4 teams, okay, winning the National Football Championship is 1/5, 1/6, 7, and 8. Probability of P winning, you write it down. Assuming only that one team can win, only one team can win the championship, we want to find the probability that either P or Q wins the championship. Okay, so the probability of finding whether P or Q actually wins. Okay, so since it is mutually, since only one team can win, okay, so they are definitely mutually exclusive events. So probability of P or Q wins will be the same as probability of P win plus the probability of Q winning. So that's 1/5 plus 1/6, giving you 11/30. This question doesn't just restrict that there are only 4 teams. There might be more teams because the probability over here doesn't add up to 1. Right? I think. Yeah, it doesn't add up to 1. Okay, so part 2, you find the probability of Q or R or S winning. Okay, so they are all mutually exclusive events. So it need not actually be just 2 events. We can consider it as 3 events as well. So we can consider 1/6 plus 1/7 plus 1/8. And that would give you 73/160. And then lastly, the probability of nobody winning. Okay, how will you go about finding that?
1 minus everybody.
Okay, 1 minus everybody, right? As in PQRS. Okay, I'm just writing it down in case you didn't catch what I'm saying. So that will be 307 over 840. Any questions about mutually exclusive events? Yes, dear.
Can we skip the 1 minus P jack of ace?
Yes. Okay, so with that we close out the 2.3. Mutually exclusive events is just like that. Okay. Next we look into multiplication law of probability and then also independent events. Okay. So other than looking at mutually exclusive events, we also look at another type called independent events. They actually don't mean the same. Alright. But before we go into that, okay, we like to actually simplify the way we draw our tree diagram first. Okay. So earlier on, okay, if we are considering, okay, a bag that contains one red and one blue ball, okay, we would, if and then after I want to actually draw out a ball from the bag, okay, and then after I draw it twice. So upon first pick, it is either a red or a blue, right? Then after that, if I were to replace the ball, okay, with replacement, after the first pick, okay, I will still have red and blue ball, okay, and then after that, likewise, I will also have red and blue. So this is for my second pick. So this was how we understood our tree diagram earlier. Okay, but you will find that what if I were to have instead a bag that has, or that contains 3 blue and 2 red balls. Okay, and then also likewise I do with replacement and after first pick. Okay, then I want to count the probability, right? So if there's 3 blue balls, then after that I might need to consider blue 1, blue 2, blue 3, okay, and then R1 and R2. Okay, I cannot have blue and red, alright? Or rather at this point of time, what we understand about tree diagrams, we cannot just have it as blue and red because they are not equally, the probabilities are not equal. Okay, it's not half chance, alright? The probability of getting a blue ball in this case is 3 out of 5. And then the probability of getting a red ball is 2 out of 5. Okay, so I want to illustrate it in a very clear tree diagram as per the skill that we know now. Then after that, if I were to replace it, then after that, end up my tree diagram will be very packed. Okay, and that's crazy. Okay, you probably this kind of question 1 mark. Okay, then after that 1 mark only need to spend 1.5 minutes, right? Then if the perfectionist over here, you probably need 3 minutes to complete this. Okay, so that's not worth the marks, right? So of course, there's a simpler way of doing our tree diagrams. Okay, so the simpler way would be, we still do blue and red. Okay, so this is the first pick. And then after that, second pick, blue and red as well. However, we will label the probabilities, okay, on the branches itself. So for instance, in this case, first pick, the probability of getting the blue ball will be 3 out of 5. And then the probability of getting the red ball will actually be 2 out of 5. Right? Then since I replace the ball after I pick it out, okay, my probability of choosing the blue one will remain the same, which is 3 out of 5. And then this will be 2 out of 5. Likewise, okay, for this one also the same. So we will label the probabilities on the branches accordingly. Okay? Any questions so far? Alright. Now, what if okay, I don't do with replacement. So this one with replacement. I mean, since we are talking about this, with replacement we consider this, right? What if without replacement? So without replacement, first pick, the probability will still remain the same, because end up also still have 5 balls inside the bag, and then after that, the number of blue is 3, the number of red is 2. But after I pick out 1 blue ball, okay, how many blue balls will there be left inside the bag? It will be left with 2, right? Okay, because I pick out 1, I will only have 3. So I will be left with 2 out of 4 bags left in the bag. So the probability change, 2/4, and then the red one will also be 2/4. So that will actually be equal to half. So please simplify it. Okay. Then after that, when considering the red one, if my first pick were to be red, okay, and I don't replace it, what would the probability of getting the blue ball be after that in the second pick? What would it be? if I pick a red one at first and I don't put it back, how many balls would there be left inside the bag? 4. And how many would be blue?
3.
So my probability will be
3 over 4.
3 over 4. Okay? And then after that, the probability of getting the red one will be 1 red out of a total of 4 balls left inside the bag. Okay? Any questions so far? Okay, so what we observe over here in our tree diagram, okay, is that in this part itself, the probability must add up to be 1. Total probability equals to 1. Likewise over here, probability will also add up to be equals to 1. Okay, it cannot be lesser than 1. Okay? Because those are the only choices, right? So usually all of them must add up to 1. Likewise, in the other case, also the same. Okay, so within that part where it branches out, right, they should all add up to be equals to 1. Okay? Replacement of the ball inside the bag, right? Okay, this is what we call a independent event. Okay, because the second pick, the probability of the second pick does not affect it. It's not affected by the first pick. You understand? So when there is replacement, okay, it will be considered independent events. Okay, whereas without replacement, alright, they are considered dependent events. So the dependency of events, right, depends on whether there is some relation, okay, to the previous event from happening or not. Right? Yeah.
No event.
Oh, sorry. Thanks. Okay, and then after when it comes to independent events, right, we will find that the probability of A and B will actually be the same as taking probability of A times probability of B. Okay? Right, I will explain why the multiplication actually works. Okay, so just write the example here. So we will consider, okay, having this bag that contains 2 red and 1 green ball. Okay, so 2 balls are being drawn at random, 1 at a time, and there is replacement. Okay, so with replacement, that means that it will be considered as independent events. Okay, because the second pick's probability is not affected by the first pick probability. Okay, rather the first pick does not affect the second pick. So we let A be the event that the first ball is red, and then after that B be the event where the second ball is green. Okay, so if we were to draw our simplified version, or rather the original version of our tree diagram, okay, our tree diagram, we will have two red balls, so R1, R2, and then after that one green ball, right? Okay, I'll explain later why I draw it this way. Then after that, my second pick, okay, because there's replacement, so likewise I will have my R1, R2 and green still, and then R1, R2 and green, and then R1, R2 and green. So my outcome over here will be red, 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 red also. Okay, so these are all my possible outcomes. Right, and I find that the total number of possible outcomes will be 9 of them.